So this problem says a stone is tied to a 0.5 meter string and whirled at a constant speed of 4 meters per second in a vertical circle. Its acceleration at the bottom of the circle is what? This is a tricky little problem, but it's not that bad to do. Just takes us to be very careful of how we think about this problem. So I have a person, they're going to be whirling around this string with a ball on it, and the ball is going to do a circular motion. So it's going to have some velocity, and it's going to have some radius. Well, I know for an object to do circular motion, if an object does a circle, it has to have a centripetal acceleration. Its acceleration cannot be anything different than that centripetal acceleration, especially, or knowing the fact that it has a constant speed. So a lot of times when we whirl around a stone attached to a rope, something on the end of a string, its speed will actually change at the top and the bottom. This is not the case. This is the case where we have constant speed around this whole loop. And we know that the centripetal acceleration is equal to v squared over r. Well, when we get to the bottom loop, the top loop, any of the loop is going to have the same value. So all I have to do is actually just substitute this in. It says it's 4 meters per second quantity squared over 0.5 meters is our centripetal acceleration. Our centripetal acceleration is 16 divided by 1/2. 0.5 is 1 divided by 1/2, which is equal to 32 meters per second squared. We know at the bottom of the circle, when it's down here, its velocity is going in this direction, which means that its centripetal acceleration has to point towards the center. It's going in this direction, the acceleration will push it more up or pull it more upward. So it has to be 32 meters per second upward. And I know you're thinking, well, why does gravity not come into play in here? It's actually because of how this problem is worded. It's asking for what's the acceleration of the stone at the bottom. It's not asking how much tension is in the string. It's not asking of how much acceleration does the person have to provide to counter gravity. So the acceleration that is this centripetal acceleration is provided by two things. It's provided by the gravity, the downward gravity, which is actually in the opposite direction, but it's also provided by the force of tension, the tension pulling up on this string. So this is a weird problem. We'll actually see some problems like this when you get into forces. This problem in particular is actually a simple form because they're just asking for what's the net acceleration at the bottom.